Hi everyone. A point P is moving in the plane so that its coordinates after t seconds are t minus sine of t, comma, cosine of t. So basically this is your x and your y. It's measured in feet. We're going to find the maximum speed of the point, and then we're going to find the angle between the velocity vector at p at t equals pi divided by 3 and the x-axis. All right, so the first thing we're going to do is have to find the velocity vector. So the thing is, we're going to have to differentiate our x and our y. So we have our x and our y, and for us, our x is t minus sine of t, and our y is cosine of t. So let's go ahead and do that. We differentiate our x to find the velocity vector. So differentiate your x, which means we're going to differentiate with respect to t, our t minus sine of t. All right, and that's going to be equal to 1 minus cosine of t. Real quick, notice that if I set this to 0, we're going to have cosine of t equals negative 1. Now we also have to do this for our y, so we're going to differentiate with respect to t our y, or for us that's going to be the derivative with respect to t of cosine of t. Therefore we have the derivative of y with respect to t equals negative sine of t when you differentiate that. So we're going to have our velocity vector is going to be equal to this one, 1 minus cosine of t, comma, negative sine of t. Now, since we have the velocity vector, I'm just going to get the absolute value of our velocity, finding the maximum speed. And that's using the distance formula, or namely, what we're going to do is take the absolute value of our velocity, and we're going to square root our derivative of x with respect to t. It's going to be that squared plus our derivative of y with respect to t squared. And that equals your, going to be equal to your speed. So we're going to have 1 minus cosine of t squared plus negative sine of t squared. Now let's expand this. This is going to give us the square root. For this piece, that's going to be 1 minus 2 cosine of t plus cosine squared of t. And this piece is going to be plus sine squared of t. Of course, we know from our Pythagorean identity this equals 1. So now I have the square root of, this is going to equal 1 plus 1 is 2 minus 2 cosine of t. Simplifying this further, I can factor out a 2. I'll get 2, 1 minus cosine of t. Now remember earlier, what I did is I wrote, I set our 1 minus cosine of t equals 0. So your cosine of t equals negative 1. So when you figure this part out, you're going to get, this is going to equal 2 square root of 2 times, and this is going to be cosine of t is negative 1, so you're going to have 1 minus a negative 1, because cosine of t is negative 1. This is going to give you square root of 2 times 2, which equals 2. And again, this is your maximum speed when cosine of t is negative 1. All right. Now we have to do part 2. We're going to find the angle between the velocity vector at t equals pi divided by 3 and the x-axis. And that simply means we're going to use the tan function. So let's look at that. For t equals pi divided by 3, we're going to have derivative of x with respect to t equals 1 minus cosine of pi divided by 3. And that's going to equal 1 minus 1/2. And that equals 1/2. And at t equals 3, we're going to have the derivative of y with respect to t equals negative sine of pi divided by 3. That equals negative square root of 3 divided by 2. And now we're going to let the angle theta, let's let theta be the angle between the velocity vector. So then we're going to use tan of theta equals your derivative of y with respect to t divided by your derivative of x with respect to t. This is going to give you, filling these in, derivative of y is here. So that's going to be negative square root of 3 divided by 2. And our derivative of x with respect to t is 1/2. The 2's cancel. So we have tan of theta equals negative square root of 3. That means our angle is going to equal negative pi divided by 3. And that's it. Thank you. Have a nice day. Bye-bye.